Hey, statistics, here is section 4.5. It's the general multiplication rule. Now, as soon as you see multiplication, get ready for this test. I want you to think of A and B. Yesterday, we dealt with A or B a lot, for the last couple of days, really, but now when we say A and B. So, let's think about it. I have students who take AP Statistics. They also take pre-calculus. There are students who take pre-calculus and not AP Statistics, and there are students who take AP Statistics and not pre-calculus, right? If I ask a senior, are you taking pre-calculus or AP Statistics? When you're going to sign up for your classes, you might say, I'm taking pre-calculus. Like, it was an either or, but not both. But if the question is, could you be one of Larson's students? And then the question goes, hey, do you take pre-calculus or AP Statistics? Then if you take either one of them, you're a yes. If you take both of them, you're a yes, right? That's how or is a little different for us in statistics than it is, sort of conversationally. And would be like this. Hey, how many students take pre-calculus and AP Statistics? Now that's a much smaller number, right? That's the difference between or and for us in statistics. Okay, here we go. Review. So far, two formulas and two organizational charts. The formulas are the probability of A or B is the probability of A plus the probability of B. I'm allowed to add the two probabilities, but it's only true under this one condition. If A and B are mutually exclusive. And unfortunately, there's another word for that. Disjoint, so you have to know one more word, and I'd rather you didn't have to. There's plenty going on as there is. The formula for A or B for any events, if we don't fall in this condition, goes like this. The probability of A or B, you've seen this before, so this should look very familiar to you. If not, you're in trouble. Probability of A plus the probability of B, and then we go minus the probability of A and B. And I'll tell you why we say that when I'm done with the Venn diagram, I think. Okay, we have a two-way table and a Venn diagram, and you know what? I'm kind of lying here because didn't I tell you the complement? Didn't we talk about the complement? I think we did already. And so I'm going to say there are three formulas, and I'm going to put one more up here. The probability of A complement is 1 minus the probability of A. If you got a 20% chance of passing this test, you got an 80% chance of failing it. It goes like that. Okay, so we have a two-way table, we have a Venn diagram, and instead of making you go to the book, apparently I was nice enough to actually type this one out. In March 2015, 57% of the voting members of the U.S. House Representatives were Republican. 19% of the House members were women, and 36 were men that were Democrats. Okay, so I got to take that information and figure out what's going on here. 57 of them were Republicans, so I go to Republican, and that's a total number over here, 57%. But this next one, 19% of House members were women. Well, that's actually a total number too. So I go to where women are, and that's going to be 19 total. But this last number is not a total number. 36% were men that were Democrats. So that's got to go inside this chart somewhere. So go where men and Democrats have an intersection, and that's 36%. Now that I have two numbers here and one in the middle, I can fill out the whole chart, right? 100% minus 19% is 81%. So if 19% of the U.S. House Representatives were women, that means 81% of them were men, and we are way off with percentages with who's ruling this party right here. 100% minus 57% is 43%. So more Republicans than Democrats going on in the U.S. House of Representatives in 2015. What else can I do? I can 43 minus 36 is going to be 7 of the Democrats were women and 36 of the Democrats were men. And then I could take 81 minus 36 and get 45. I can take 19 minus 7 and get 12, and I've got the entire two-way table finished, so I could start answering questions like this. I prefer the two-way table. I don't prefer the Venn diagram, but some people do, so I'll show it to you. I've got two things going on. I want to make one circle, so I'm going to make the circle out of men because there are more men in this scenario. And so this circle represents the men that are in the U.S. House of Representatives. And here, I'm going to pick one of these, and there's more Republicans, so I'm going to have this overlap here, and I'm going to say Republicans. Okay, so I basically turned this into a men variable with yes and no, and a Republican variable with yes and no. That's kind of how we did that for the Venn diagram. Now, the first number I'm always going to put in a Venn diagram is the intersection. Men and Republicans. And. Men and Republicans, that's 45. Okay, so let's go back and start putting some stuff in here. 57% of the voting members in the House of Representatives were Republicans. So you guys, what that means is this whole circle has to add up to 57. So I've got to take 57 and subtract this 45 here, and when I do, that ends up with a 12 for this part. So the circles aren't really drawn to a correct ratio, right? But it doesn't have to be. So these two, if you add them up, you get all of the Republicans, and that's 57%. For the men, let's see, 19% of the House were women. Okay, so if that's how many women there were 81% was men. And so this whole big circle has to be 81%. So if I take that 81% and subtract the intersection, the ones that are men who are not Republicans would be 36 right here. Okay, and then this whole situation has to add up to 100%, and these numbers don't add up to 100%. So I can add them up and subtract from 100% and find out that 7% are women who are Democrats, as you can see in the two-way table. You generally don't make both of these for a problem. You do that one or you do that one. Taking this kind of information and putting it in one of these, I really prefer this so I don't have to do all this subtracting. However, once I have the subtracting done, I kind of prefer using the Venn diagram to answer these. So they both have goods and bads. Randomly pick a representative, find each probability. Okay, so and. Democrat and man. Let's go find Democrat. Let's go find man. That's going to be 36 out of 100. And 36 out of 100, of course, is 36%. The probability of randomly picking a U.S. representative and finding both a guy and a Democrat is 36%. Now, man or Republican is different. The or makes a different problem, and you guys got to watch for it. So that's going to be the probability for man, 81 out of 100. Plus the probability for Republican, 57 out of 100. But then I have to subtract off of that the intersection. Because if you add up the men, 81%, and if you add up the 57% for Republicans, you just counted this middle part twice. And this number will be way too big. You can tell it's over 100%. So I subtract off the intersection, subtract off 45 over 100, and I get 93%. Now, how did I know that was 93%? Because only 7% are women who are Democrats, right? Man or Republican. That's a man or a Republican. It's a man. That's a man or a Republican. It's a Republican and a man. That's a man or a Republican. It's a woman, but she's a Republican. So these three, you could just add together and just leave out these 7 women. And if you add these up, you're going to get 93. Or if you use the Venn diagram, man or Republican is man or Republican or both. You could just add these 3 numbers up and you could get the 93% that way. But I used the formula, and I want you to see it up here again. Man or Republican. Probability of man, 81 over 100. Probability of Republican, 57 over 100. Minus the probability of man and Republican, the 45%. So you've got an equation, a two-way table, and a Venn diagram. All good options for the or problem. The and problem in the, let's see, man and Democrat. So here's men. Here's men that are Republicans, so that has to be men and Democrat right there, the 36. Or here, it's even easier, men, Democrat, 36. Suppose you randomly pick a representative. Oh, here we go. And you know it's a Democrat. That's new. Now I'm putting a condition on the information that you know. If you know the person is a Democrat, then all of these people where I'm going to put my pen, they don't matter anymore. They're off the board. If I know the person is a Democrat, there's 36 guys and 7 women. Everybody else is no longer part of this problem. If you know it's a Democrat, what's the probability the representative is a woman? It's still these 7 women right here, but it's no longer out of 100. It's 7 out of 43 Democrats. So 16.3%. So there's a new wrinkle for us today that you haven't seen before. If I give you some previous knowledge, I'm putting a condition on information you know, that's going to eliminate part of the two-way table. All right, let's go to page 2.